Good morning / afternoon. I'm Andrea Mocci and here to talk about design and effectiveness on internal DSL in Scala. For the ones that don't know me, I live and work in Lugano and in a research and development lab called Code Launch, which is part of the Software Institute at Università della Svizzera Italiana. So what I do, my title officially is junior group leader, which means essentially that I do the technical lead. I am a technical lead for the projects that we do. And I also teach to my students a course on domain-specific languages, and this is like some talk that is distilled from that. So let's start from the few ones that don't know what a domain is, so just in a very general point of view. So a domain in a specified sphere of activity or knowledge, okay? Like the domain, the country's isolation, the domain of sport. And obviously, since you know the software is like eating the world, you know that many times you have to interact with domains that you don't know anything about. Like in this slide, I'm just using as a problem domain, so domain of the software act, the domain of logistics, and then you can think about the software as the solution domain. So something that is going to solve your problems in the solution domain. So there's an entire area of research and disciplines in software engineering, which is called requirement engineering, which is, if you want, dedicated to bridge the gap between these two worlds. So how do you write software in order to understand and maybe solve your problems in a given domain? But there are other ways to gap this bridge, and this is what I'm going to talk about today, which are domain-specific languages. Okay? So domain-specific languages are essentially languages, like computer languages, that are targeted at describing the entities in a specific domain, or solving a problem related to a specific domain. If you have been a language engineering, maybe when you were a student, or if you do it nowadays, for example, you might have used something like NTLR, which is a DSL to describe and generate, a construct parser generator. So with that, you can really construct the language that you want. You can probably modify an existing compiler, okay? But obviously, you're not talking about this. I'm talking about DSLs. So the point of the DSL with respect to a classic general-purpose programming language is the following. So what clearly differentiates a DSL from a general-purpose programming language is its limited expressiveness. You can model anything and everything with the general-purpose programming language, like, for example, Ruby or Python or Scala or Java. But with a DSL, you can model only one specific domain, but in a more expressive way. I wanted to quote this. This is an approximate quote by one of the leading living experts on domain-specific languages, which is Martin Fowler, here in the picture. You probably know him for his book on refactoring, but there's also a book, a very beautiful book on DSLs, and in the website there's a lot of stuff about domain-specific languages. So let's slightly talk about classifications, just because I'm going to tell you also what I'm not talking about today. So external DSL is the first form of domain-specific languages, which are essentially developed ground up. They have their own ad hoc syntax and semantics, and they have their own lexers, parsers, and analyzers. To build something like that, you need to be a language engineer, so you really need to know how to construct a parser, how to, for example, create a syntax highlighter if you do it manually, or to use, in some cases, some language workbenches that will help you construct all these tools. So all the pipeline of tools for the DSL. But what I'm talking today is more about internal DSLs, which essentially are built on top of existing programming languages, and they share the syntax with a programming language of choice, meaning that an internal DSL is, for example, an internal DSL for Ruby, for Scala, for Java, slightly less commonly, but that's the point, okay? And the point and the message that we'll have at the end of this presentation, hopefully, is that they require certain features to be expressive. So the general purpose programming language on which you build your DSL on top needs to have some features to produce something which is effective in the purpose of the internal DSL. And I'll talk about this in the next few slides. So an internal DSL has many forms. One of the easiest format you have is the so-called fluent interface. These are APIs that have a declarative language-like flow. So you read some code, and that this API reads like natural language. It reads like you're reading a natural language specification of something, okay? You probably have seen it many times, but never realizing exactly that this was the case. And this idea of having a fluent API is probably the simplest form of an internal DSL. And you can do it almost with every language, okay? Actually, with most languages. So, and the point is that some things, when you use a DSL, may slightly change. So let's focus, for example, on conventions on naming methods, okay? If you take the official Java documentation, you will see that there are many things that are recommended. For example, naming a method, okay? And in fact, the documentation said the method name should be a verb in lowercase or a multi-word name, blah, 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 okay? And these are the examples like run, run fast, get background, and so on. So if you look, for example, at the Google style guide, method names are typical verbs, voila, or verb phrases. For example, send message or stop. Is this true for any, like if you take the JDK or take the Google APIs, is it true always? And I would say no. For example, this is Java 11, like part of the JDK, and these are methods in the list interface. So these are default methods that are useful to construct immutable lists. And this is not even a noun, so it's a particle, and it's just of. So this is the name of the method. Why you have something like that? Well, it's not JDK, obviously, but obviously you have it also in the Google Guava documentation. So the point is that this is like the smallest fluent interface that you can find. It's declarative. It doesn't say what the method does, but it reads well. You understand that when you like read it with the name of the class. Never try to import statically of, for example, in Java. Never try to do that because then it would break this readability, okay? And it reads well only with the interface name and really expresses the property of the return list. So it's the list of 3, a list of 1 element, okay? There are more stuff. This is like probably the pioneering API that did a very beautiful fluent interface. Not only here you have something that reads like natural language. So for example, allowing calculator dot square root with less than 0 will throw an exception, which is new illegal argument exception. Not only this, but even this space is not there by mistake. The authors of this library wanted you to write the code in this way. So put a space here and to put this indentation in this way, because that's the way you should use this particular language. There's a beautiful paper which is called Evolving an Embedded Domain-Specific Language in Java. It's from the mid-2000s and from the creator of JMock, and they describe the evolution and the construction of this. And essentially, I want to read this because it's appropriate for DSLs, but it's appropriate also for, let's say, even if you don't realize it, on how you program, okay? A good programmer in this time does not just write programs. They do language design, so not from scratch, but building on the frame of a base language. It could be the general purpose language, or could be some DSL you're using. And every program, indeed, is like a language. You're talking about a domain. For example, if your software operates on a given domain, and maybe confused and implicit, but at the minimum bare, there will be convention and programming interfaces that color the structure of a code. And that's, I think it's really a beautiful quote. And that's how the paper starts. If you want, I will publish something on my GitHub page with these references. And the idea is that, well, this is how you can do this in Java. Now that the authors did it in Java. But today, I'm going to show you how it works when you use, instead of Java, a language that has more features to make a fluent API fluent, so to express fluency. And so today, we'll talk about internal DSLs in Scala. So what I will do is actually just code a very, very simple DSL, which is probably just ignore that for the moment. So a very simple DSL. And let's consider the domain of logistics. So what I will do, this is Visual Studio Code. So I have essentially, I want to express something in the domain of logistics. And for example, I will start with quantities, like scientific quantities, for example, to express a length. And I will build on top of this. Now, if you don't know Scala, you don't have to worry about this. Is just a class. which holds a value and a unit of measure. And imagine this unit of measure here, like an enum, and with I have two values. I can express just miles and kilometers, and I have some, you know, some very simple mechanism to convert it to meters, just to allow to do a conversion between one measure and the other. Okay, so then I have my script that, for example, can import the quantity DSL and then the testing DSL that I will build later. And this is how you create a length in Scala. Okay, by invoking, let's say, the constructor of that class that I wrote. It's not really a constructor, but you can think about it like that. So what's the problem with this? Is that it doesn't really, it's not fluent, not because it doesn't really like natural language, like actually it doesn't really, but because it doesn't follow the typical notation that you use for unit of measures, right? What you would like to define, for example, sorry, it's something like this. It's something like, for example, like this. Or maybe without this dot, but it's the same. Now imagine it like with this dot. This reads like 10 kilometers. It reads like the notation you used in the school, for example, in middle school and so on, and the notation that even a scientist which has no probably education in programming, even if this thing is rare, could have, okay? Obviously, this is a very simple example, but I argue that this case is more readable. So what's the point? So how can you define something like this in Scala? Obviously, the compiler here is like complaining the value km is not a member of double. So obviously, because this method does not exist on double, you can call methods on double in Scala. So, but what you can do, it's essentially define in your DSL something to add this km method to a double. And this thing is called implicit class. So imagine like really a mechanism to do method extensions. So really to add a method to double, but not in a global scope. What you want to do it is just in the scope of a DSL, okay? So let's call it unit of measure decorator, for example, or extension. I can get a value, which is a double, and I will define my method kilometer, which will create a length of value, so the thing that I will box, that the compiler will get, and the kilometer. So now the thing compiles, and the two things are completely equivalent, right? So this thing reads better, I argue, and the people that write down internal DSLs use this everywhere, and it's used everywhere in Scala. I will give you a couple of examples later. And that's the idea, okay? For example, I can also define imagine your logistics software is working also in the United States, and you know, you will have to take into account miles, for example, and conversion between kilometers and miles, okay? If your business works also in the United States. So now I can also define val length 3, which is, for example, 5 miles, okay? And that's the idea. Yes? I can get rid of the dot, but I have to, in this version of Scala, it's not really recommended, okay? I can describe it like offline how you do it. You have to enable postfix operators, and then you can get rid of the dot, okay? Very good. But then it doesn't combine very well with the rest of the things that I will tell you now. So you don't, actually you're better not use it, okay? So very good question. So, but in theory you can get rid of the dot in some context. So now I've done this, and for example, what I can do now is something like, imagine I want to add some kind of operator, like I want to add length 2 here. So as you can see, the compiler is complaining because this operator is not available, okay? But the cool thing is that in Scala, this is not really an operator, so there is not really operator overloading. In Scala, everything is, even this, is actually a method call. And the idea is that this method call is the call of a symbolic method, okay? Which is very particular. So for now, just let's write it down like this. and then I explain you what's happening actually. So let's define a plus method, def plus. Actually, I have the implementation because you have to convert the unit. So I'm going to import all this stuff, which defines the plus, the minus, the multiplication, and some more stuff. And now I have it here. Voila. And now I can sum, but there is one thing in Scala, which is the infix form. So whenever a method has only one parameter, you can call it like it is an operator, like it was an operator. So without the dot and without the parentheses. But obviously only if it has one parameter, obviously if it's defined on a certain class. It's slightly more generic than this, but this is how it's called. If you have noticed, I also have a method here which is called to. And actually, it's not just for symbolic methods. I can, for example, call, I don't know, 5 miles and convert it to kilometers. So this method 2, which has one parameter and it's just like any other method for converting from one unit to the other, I can use it in an infix form again. And that's the cool part. And you can actually combine that. The only problem is that if you combine that, you have to follow certain rules, okay? So, and I'm going to explain it to in a while how this works. But that's the idea. If you have one method with one parameter, you can call it in an infix form. You don't have like in Kotlin to put the infix keyword. You can do it directly. You can call it in the same way. So this allows, for example, let's imagine now I want to do a little testing because I'm not very comfortable of the kind of conversion I have done. So imagine I want to do something like this, length 2 should be equal to 10.0 kilometers. Okay, I have something like this, which is like similar to the kind of assertions you have seen in the previous talk, the one you have in any testing framework, that they read in a very fluent way. So and the idea here is that you want to write something that it's more abstract as possible for two reasons. One is because at least someone that didn't write the code that you're testing can understand what's happening, can immediately understand how the assertion is constructed, and can do some more complex stuff. Like this code could, for example, actually, since it can understand what is the expected value, construct automatically some message, okay? So the point is that here you have multiple methods that are called in the infix form. And the cool thing is that whenever you have a symbolic method, it usually takes more precedence than the ones starting with the letters. So in the end, this thing parses for Scala like this. Why? Well, I'm going to just like show you a slide, which is this one. So whenever you have infix forms, it all depends, the precedence is determined by the first symbol of the method. So all the other symbols, the most funky ones, have very high priority, and the other ones get lower priority by depending on the symbol. And so this is like very similar to the precedences that you get in default math operations, right? So this makes sense. There's sense for all the others, but you may think about it or read the Scala documentation, okay? So in this way, this is the kind of thing I have to construct. I have to do, well, define should, in this case somewhere, and also define some kind of word that I use for my DSL, which is this B, okay? So let's start from this B, okay? In my testing DSL, so only here, I can define a word, so like a singleton object that is useful for my DSL. Well, in Scala, you have singletons, if you want, automatically defined in the language, and you can do it like this. Now, see, this thing violates definitely any naming convention that you normally have, but you can do it because when you devise a DSL, you can break those conventions with impunity. The reference here is just fluency, okay? And here, you can define, for example, an equal that we take, for example, a length. Let's call it other. Let's call it other length. And that will return something, okay? For now, let's just make it not implemented, which is the way you do it in this way. Okay, I'm missing should. Okay, and well, let's define should. How can I do it? Well, I could define it up here because I already have some kind of decorator. Well, no, I have length up here, so I can define should there. But actually, it's not the best practice. What I really want to do is just have should in the testing framework. So I will define it in the testing DSL, and I will use an implicit class to do that. Very good. So now I have it a testing length decorator. Obviously, that will take some length, which is a length, and that will define the should method. Okay, it will take some param, and now we'll define what it is. We'll just define it as any possible object. That's how we do it in Scala, and voila! Now everything compiles. And if I get rid of all the parentheses, it's exactly the same thing. This should is this should, this equal is the equal defined up there. Okay? So, how do you do that? Well, I want to just use some functions because still this is Scala. So I want something here that returns nothing. So this is like a void. It's taking a length and will do something. And this something is, will take a length and will assert something, okay? So I will assert trivially that length equals other. That's the idea. So I like creating a lambda. So this equal, we create a lambda because at a certain moment I have to bind it to this length too and execute the assertions, okay? So the cool thing now is that here, instead of a param, I can take, well, let's call it param. No, let's call it assertion. And we'll take a function from length to unit, okay? And what I will do, I always spell it wrongly, sorry. What I will do is simply invoke the assertion on the length that I have up here, okay? Voila. And I have finished a mini DSL for this. Obviously, this is like, this works in a way. I can actually try to invoke it in SPT. Voila, it works, okay? There is no violation because length 1 is 10.0, but now I will do some kind of violation, okay? Obviously, if you're doing some kind of conversions like this with miles, you don't want exact equality, right? For example, you may want something like a tolerance of, I don't know, 1.0 kilometer, okay? And that's the idea. I'm kind of missing this plus or minus method, which has higher precedence than this equal. And in fact, I would like to define it somewhere. And I have it defined somewhere, I think. If I didn't, I will do that. Here it is. For example, I can define it just for testing. And I will show you how this thing works, okay? So I'll define it just for testing when decorating the length. So I can do it here. And the idea is that I will return a range, which is a tuple. And this tuple is length minus tolerance and length plus tolerance, okay? And now, what's the problem? Is that this equal was taking a length. Now I have a tuple, so I have ranges of lengths. And to make it work, what I can do is just do a tiny overload of this equal method, that instead of a tuple, I will take, sorry, instead of a length, I will take a tuple of lengths. And now I want that the length is greater or equal than the first value, the first length on the range, and the length is less or equal than the second range, second value on the tuple. Voila. And somehow I have created a very simple DSL that now has this kind of tolerance embedded. And by designing well these operators, I don't have to do anything strange and don't even put a parenthesis, right? And obviously, you may think about if this is readable or not. You just have to use things when you use symbols that your programmers are familiar with. So something like that makes sense with the notation, okay? Now, imagine I'm doing something like this. Length 3 should be, I don't know, 5. Let's say it's around 10 miles, probably, plus or minus, let's be safe, 2 miles, okay? Well, let's use even 1 kilometer. Let's use 1 kilometer. Let's make it fail. And maybe, even again, you want to do length 4, should be, I don't know, 5 miles, plus or minus, again, 1 kilometer, okay? So let's even do 5.9. So what's bad here? What's bad? You have some kind of repetitions. And one of the things in the Scala you can easily get rid of are things that are repeated. Why this plus or minus 1 kilometer, if you're using it repeatedly, should be avoided? Because there is a concept here, which is the tolerance, which you would like to define at a certain moment, for example here. And then you would like your DSL to consider it automatically. Well, for example, if you use some kind of operator that implements a form of approximate equality, okay? That I, for example, can do it like this. Now, I didn't define it. So the idea is that I want to define approximate equality with some kind of tolerance, okay? And I can do it, again, similarly, by defining a method on B, which will have the same precedence when we start with equal, and that will take another and the tolerance, okay? And you take a tolerance as a length in the following way. So, well, let's just implement it, okay? What I will do is just call this dot equal with what? With essentially the method that I defined before, tolerance. Voila. And now, what I can do is essentially reuse it in this way. What's the problem is that I should pass the tolerance automatically. Now, the compiler is not complaining that I'm not passing the tolerance for a reason that these now are just functions where it's missing a parameter. But the idea is that you can automatically bind it with the so-called implicit parameter, okay? In fact, now it's complaining because they couldn't find an implicit value. So what are implicit values? Implicit values are like some kind of contextual values that the compiler automatically inserts when it needs them, right? So if you want intolerance to be defined in your DSL where you have approximate equality, what you have to do is just to provide this, okay? This is used in Scala for thousands of applications, like, for example, execution environments for example, when you do asynchronous computations, but it's used like everywhere, and it's actually source of probably 80% of the errors when you're trying to copy-paste code from Stack Overflow. If you have tried it, it's just because you may be forgetting to define or to import something that is implicit, okay? That's the idea. So we have come from 0 to a very simple toy language that I could run, and obviously this will probably fail because these comparisons that I've done are actually bad, and in fact, that's it, an assertion failed and a certain thing. Also, being lazy on defining the assertion error, so these are not very good. But fortunately, someone has implemented this thing in a good way. So, I've done a little demo of internal DSLs in Scala, and I'll show you things like features that can help you define this. For example, like implicit classes that are useful to do extension methods if you want. You can think about them in this. And these extension methods in this particular form, where you have units, are commonly used in Scala, for example, for durations in seconds that you use in Akka, but actually defined in Scala itself, okay? Or we've seen infix method calls that reduce like some kind of the clutter. And actually, if you read the documentation for symbolic method names, well, these are the cases where you can use them with impunity. Otherwise, they're going to tell you don't use symbolic method names. Try to not be creative, and there are even guidelines when you should not use them, okay? For example, maybe mentioned in C++, they tell you, okay, this should not be used for writing to an output stream, okay? This is not acceptable. This is what they think, but maybe a C++ programmer may not be agreeing with this, okay? So that's the idea. Now, I talked about precedence with infix forms, and I talked about implicit values, okay? Which are useful when you model something contextual. And for some specific class of domain-specific languages, which are the ones very, very functional that unfortunately I cannot talk about, these things are used especially to model type classes, okay? If you're curious, if you're programmed in Haskell, that's exactly the way you do it, okay? Use implicits for that. Okay, you may think that what I presented are simply some kind of toy DSLs. It's true. What I've done is just a toy DSL, or a particular kind of toy. It's like a Lego DSL. What do I mean? That really these are simply very, very little building blocks that are actually used in real, like daily APIs in Scala. This is one of my favorite, for example, for quantities, units of measure, and dimensional analysis, developed by type level. It's called Squants. And it's actually very, very effective in doing this. I will give you some examples on how effective this is. For example, you can do conversions like I did. It works slightly different, but see, they prefer not to use unit, but to expand them. For example, converting pounds to kilograms and obtaining directly the value, not converting the things. Or you have something like conversion between centigrades and Fahrenheit. Again, in certain domains, this is extremely important. But you can do something more powerful, obviously, because here you have a full modeling of this stuff. For example, here, create quantities using operation between other quantities. You can multiply kilowatts and multiply kilowatts with time, and you would get some energy in watt hours. You can, for example, get the price of some USD per megawatt hours. And you can imagine you can do a speed in miles per hour, and by default, it will get the value in meters per second, okay? And again, you can do something even with information, frequencies, or stuff. There's really, really a lot implemented there. So this is for your curiosity. And for testing, this is probably the reference testing framework. It's not the only one. It was one of the first that supports really, really a lot of different things. And I want to show you how it works, okay? So this is kind of resembling the style that you would have in testing frameworks like, or specification frameworks like RSpec, for example. In fact, this is written like a specification if it's not properly. So for example, a stack should pop values in last in first out order. So this should now is extending probably, and certainly, a string. And why do you have it in this form? Because then you can create really meaningful error messages, okay? And in fact, then the assertion has a form like very similar to what I have done. A more creative that I really like solution is the one done down here. You have it, which is not the same it as in Kotlin, but it works in this case in a very similar way. It means they should consider the string that you have defined before, essentially still about the stack, should throw no such element exception if an empty stack is popped in. And then you have this piece of code where you have a very, very nice assertion about the exception. And here, if you see, you have the thing that I described to you before. There is a space here, and this is a generic, okay? This is like, this A is a particle, it's a method which is a particle, and it takes a type, like a generic, and then you have should be thrown by this piece of code. So as you can see, if you have a language which allows you to do these things, you can really, really be creative, okay? Well, you can even integrate it with stuff like Selenium. And again, the idea is that you can do stuff like go to a certain URL, and the page title should be something, and so on. So this is all about, the typical frameworks that you have in Scala. I want to show you one particular advanced feature that allows you to solve a problem that you always have with these frameworks. So I used primitive types, but the problem is most of the times you need to have assertion on object of arbitrary types. And in fact, that's what you would like. Like you have a box which has a weight and a mass, some dimensions, and you want to have some mechanism to like talk about labels and weights. So to talk about something which is arbitrary, right? It's these methods should be defined they cannot be defined in the testing framework because they talk about an arbitrary type, but they should have these forms. So it should have they look like all the other things. They look like methods. They need to look like methods because then this API can read like natural language. So how do you do that? Well, you have to use something that is called metaprogramming. Essentially, these are features that allow programs to manipulate their own data. And you can, for example, read, generate, analyze, and transform other programs, even at runtime. Okay? There are two ways to do it. One is with reflection, and one is with macros. Scala is both, even if the reflection is not like small talk, it's more like very powerful introspection, but it's very close. So commonly, they allow you to examine, introspect, and modify the structure and behavior of programs, typically at runtime. And it reifies things like methods, expression, and ASTs. So I'm going to show you, for example, how ScalaTest solved with reflection the problem of testing that I showed to you. So in ScalaTest, you have something like this. So the assertion that I wrote to you, it uses this thing here, which is a symbol. So in the end, you have this tuple, and then you can really, with reflection, actually construct an assertion which will talk about the fields of a box. What's the problem here is that if you're like me, sometimes you put some typo, the compiler will not complain and that will fail at runtime, okay? And that's a serious problem because in Scala you would like something to fail at compile time, like for a simple thing like this, because the wait method does not exist. And in fact, you can do better with macros. So macros are like patterns that specify a certain input sequence can be mapped and rewritten. And the idea is that you can take a piece of code, analyze it, and rewrite it like you want, okay? I'm going to show you how this works in another testing framework, which is very cool. It's called Specs2. So this is an assertion that says, okay, box must match a box, just like in instance of, but then you have a method, label my box, and then you have some methods that can be chained. So it must match a box, width, my box, a weight, and some dimensions, such that they must have size 3, okay? The idea is that here you have something that this label, weight, and dimension method, these are not the methods of a box. These are methods of something automatically generated by this matchA method. It will generate a matcher that you normally would have if you do this manually, even in ScalaTest. But this is generated automatically according to the declaration of box. So this piece of code will analyze box, and since it has 3 fields, will generate 3 matching fields, which are these 3. And the third one actually can be even integrated with something like further assertions. And this is extremely smart. Now, if I put a typo, the compiler will complain, okay? And this is a form of very effective metaprogramming that, again, it's one of the things that in Scala people used a lot. It caused headache everywhere. And in fact, I'm going to tell you also how it's going to change recently. So these methods, matchA and matchN, obviously, because you need to be fluent if the type starts with a vocal. Then they are macro implementations. And they work like this. Essentially, this piece of code will construct something, match your class type and a class definition. So imagine some code that creates a class definition, which will be plugged in during compilation. And here you even have some code that represents a call of a constructor, right? And then there is a little transformation, which is due from the fact that this thing is quite complicated, okay? There are, obviously, if I go it would be extremely cool, but this probably would be long, other 2 or 3 talks. So, as I told you, this is like one of the coolest features, but also one of the most problematic because they were extremely powerful. So beyond Scala 2, what's happening? So if you're thinking to learn Scala and you don't have a lot of time, maybe wait at least a couple of months because the next generation is coming up. Now it's still the code name of the next version is called Dotti. It's a next generation compiler. It's becoming feature free like these days, and it will become the core for Scala 3. And what you will have? You will have implicit anymore. So there will be no implicits, but still the things that I've shown to you will be working just with different constructs. They will allow to have explicit extension methods, something like implicit instances, but they are called given, and they work slightly different. And explicit support for take class derivation, if you like very hard functional programming, okay? But most importantly, the macro system will be improved, and it will work essentially in a more clean way. And I believe, for what I have seen, that even people that are not used with macros, they maybe remember macros from Lisp, they can use it way more effectively because really, with respect to the code that you have seen, they work really, really better in a very, very elegant way. They are not so powerful, but still are very good. And I want to show you, you also have indirect support for builder DSLs a la Kotlin, which is the last thing I show you in the last minute, which is something like this. So you can essentially construct, this may look like some kind of very, very primitive builder pattern if you don't like to write down, like me, YAML or JSON, for example, right? Or you can describe the construction of complex objects in a more fluent way. Here I have table, rows, and cell indented in some way. I have some problem with the specific version of Dotti, so it's not compiling complete. So it's compiling, by the IDE is complaining, also because probably we touched the extension too much. But the idea is exactly this. You have some new constructs that will allow to do this in a very elegant way. But this is like a teaser. So I'm essentially finished. So, I talked about domains, internal DSLs, maybe a part about fluency, symbolic method names, some Lego DSLs and other Scala features that will allow you to define domain-specific languages in an effective way. Then I'll show you how these things can be extended with real DSLs and some advanced features that really make Scala effective when building domain-specific languages. And in the end, I talked about how things are going to change soon with Dotti, with just a teaser, because I would like to do that, but obviously the time is finished. Thank you very much, and this is all. So there was already a question, but I don't know if there is any other question that you have or curiosity that I can satisfy. Okay, I'm happy. I hope you enjoyed this talk. And if you want to stop me and talk about anything, even about Code Launch, feel free to do it, okay? By the way, you will find something around with this logo. You will find some little flyers. Please check them, okay? Thank you.